So we're looking at a midsegment of a triangle. A midsegment is going to be a segment connecting the two midpoints to the sides of a triangle. So I'm going to start with my triangle A, B, C, and I'm going to have midpoints D and E. Since those are midpoints, I'm going to label here, showing that they are midpoints. So D and E are midpoints. That means that segment DE is a midsegment. So what does that mean? So if we start with the midsegment, first off, we get that it is parallel to the third side. So parallel to the third side. Now that third side is the side that it doesn't hit for the midpoint. So I have a midpoint on AB, a midpoint on BC. This side it doesn't hit, so of course it's going to be parallel to that. So we'll write DE is parallel to AC. What we also have here is that it's half the length of the parallel side, or the third side. So that means that DE is equal to 1/2 AC, or AC is equal to 2 times DE, depending how we look on the scenario. So it's parallel to it, and it's half the length of this side. So now what we could do is we could take one midsegment and do this 3 times within a triangle, and I end up with 3 midsegments. So if I look at the length portion of it, I know of A, B, C, and we'll label the other ones E, D, F. I know that BD and CD are the same because they are midpoints at D, so we know BD is equal to DC. Also, since EF is its midsegment, EF is equal to 1/2 BC. But if EF is equal to 1/2 of BC, EF is also equal to BD and DC. So this little unit marking here works for this part, this one, and this one. They're all the same. We could change it around. Maybe now instead of EF is equal to 1/2 BC, BC is equal to 2 times EF, which is saying that if I doubled the midsegment, it would be the whole side. And what's nice is this works all throughout the triangle as long as you're matching up the midsegments with the correct side. So we actually get 3 sets here. Now connecting back to what we did previously with congruent triangles, I have 4 congruent triangles here, and they're all congruent by side, side, side because they have one side of each. So I have a triangle, 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 and this one rotated around. Now, when we look at the parallel part of it, we're going to use some parallel symbols here. And we'll label A, B, C, E, D, F. So I know that AB is a side. It's parallel to its midsegment DF. I know that BC is parallel to EF. And I know that AC is parallel to ED. So I have the lengths, and then I have the parallel portion of it. So now we're going to take and look at a coordinate proof to verify the midsegment theorem that we're talking about. So use the midpoint formula to find the coordinates of D and E. So the coordinates for D and E, D here is on AC. So I'm going to use the midpoint formula. The midpoint formula means if I have C at 0, 0, and A at 4, 6, I'm going to go 0 plus 4, because it's the average of the x values, and 0 plus 6, because it's the average of the y values. That gives me 4 over 2, 6 over 2, which is the coordinate 2, 3. And if I look on the graph, that does seem to be where D is. It's at 2, 3. E, I'm going to do the same thing. E is using the coordinates C and B. So we're going to go 0 plus 6, so that's the x values, over 2, and 0 plus 0 over 2. So that gives us 6 over 2 and 0 over 2, or coordinates of 3, 0, which if we look are the coordinates of E, so 3, 0. But we used here midpoint formula to show that works, so we verified that as those are the points. Now we're going to show that DE is parallel to AB with the slope formula. So I'm going to find the slope of DE and the slope of AB. So slope, we should know, is the change in y over the change in x, or y2 minus y1 over x2 minus x1. And when we say the change in y and x, we just mean we find the difference of the two. So for D to E, I'm going to start from D and go to E. So the y values, it goes 3 minus 0 and 2 minus 3. So I get 3 minus 0 is 3, 2 minus 3 is negative 1. This gives me a slope of negative 3. From A to B, I'm going to start at A and go to B. So I'm going to go 6 minus 0 is my y values, and 4 minus 6 are my x values. That gives me 6 over negative 2, which is negative 3. So now we can say that DE is parallel to AB because their slopes are equal. For the last part, we're going to show that the length, that DE is equal to 1/2 AB. So I'm going to use distance formula for DE. Distance formula we can write as the change in x squared plus the change in y squared, like we had up here. Change means you're just finding the difference, so I'll write out the longer one as well. So maybe x2 minus x1 squared plus y2 minus y1 squared. So for DE, from D to E, my x values, it will go 2 minus 3, that quantity squared, and then 3 minus 0, that quantity squared. This gives me the square root of 2 minus 3 is negative 1 squared, and 3 squared. Whenever we square a negative, we have to make sure it's the positive result. So negative 1 squared is 1, 3 squared is 9, and we get the square root of 10. Now for AB, same thing. AB, we're going to go 4 minus 6 squared and 6 minus 0 squared. So now we have 4 minus 6 is negative 2 squared, and then a 6 squared. We get the square root of 4 plus 36, which is the square root of 40. Now 40 is 4 times 10. So we can simplify that radical because the square root of 4 is 2, and that comes out to be 2 root 10. So at first look, if we say that DE is half of AB, if I took half of AB here, 2 root 10, took half of it, got rid of the 2, it's equal to that value. Over here we'll write it out that DE is 1/2 AB. So DE is the square root of 10, and that's equal to 1/2 times 2 times the square root of 10. On the right side, 1/2 and 2 just become a 1, so it shows us the square root of 10 equals the square root of 10. So it verifies with the distance formula. Now we're going to solve some problems using the midsegment rules and find some missing values that we have. So L, M, N are midpoints in our triangle PQR. We know that PR is 46, PQ is 40, and LN is 17. So instead of going through and finding these values, I'm first going to kind of go in and label what I know, and then it's easier to pull from the values I want. So I know if this is 40, that MN is going to be 20, because it's a midsegment. 46 is going to make LM 23. QR over here is going to be 34, because I doubled 17. So now I know the inside and the outside values. So now as I go through, LM is 23. MN is 20, QR is 34, and MR, which is half of the 34 because these are both 17, will be 17. For the next problem, I need to find BE. So I need to find this portion. I know that CB is 11x minus 25, and CE is 4x plus 1. Well, here's what we know. We could go CB is equal to CE plus EB. I could also say that CB is equal to 2 times CE because it's a midpoint. Now that's going to be a little bit easier to solve with, so I'm going to double this to get it to match. So we're going to say 11x minus 25 equals 2 times 4x plus 1. We get 11x minus 25 equals 8x plus 2. I'm going to subtract 8x to the left side, and I get 3x minus 25 equals 2. I'm going to add 25 over, and we get 3x equals 27, so x equals 9. Well, I know that CE is equal to BE because of the midpoint. So if I substitute in a 9 into 4x plus 1, 9 times 4 is 36, plus 1 is 37, so that means that BE is also 37. For our next problem, we need to find RT. RT is this segment on the outside, it's the side. I'm not going to set these two equal because this is a midsegment, so let's say that PQ is equal to 1/2 of RT. So the midsegment is equal to half the side. So that's going to be 15x minus 7 equals 1/2 22x minus 6. And my other option here is to put the 2 times on this side, but I'm going to do the 1/2 here because these are both even numbers and it's going to be easier to take half of. So then I get 11x minus 3 on that side. We're going to subtract 11x over, we get 4x minus 7 equals negative 3. I'm going to add 7 over, I get 4x equals 4, and that gives me x is 1. So RT is 22x minus 6, or 22 times 1 minus 6. 22 minus 6 gives us an answer of 16. So RT is 16. Next problem, I have midsegments again. I need to find the perimeter of both triangles. So let's see what I know already. Since MJ is 42, KM is 42, which means JK is 84. I also know, since this is 84 and each of these are 42, that this side, NO, is 42. And then because MN is 49, this side, JL, is 98. So we know 2 of the sides in the outside triangle, 2 of the sides on the inside triangle. We just need to solve between these two, find their sides, and I can find the perimeters. So I could either double 6x minus 1 and set it equal to 13x minus 10, or take half of 13x minus 10 and set it equal to 6x minus 1. The doubling is going to work a little bit better. So we're going to say KL is equal to 2 times MO. 13x minus 10 is equal to 2 times 6x minus 1. So by multiplying, we get 12x minus 2. I'm then going to subtract 12x over. I get x minus 10 equals negative 2, which becomes, after 10 adding over, x equals 8. We're then going to substitute that in. 6 times 8 is 48, minus 1 is 47. If by doubling that, I should get 94 here for KL. And that's also 8 times 3 is 104, minus 10 is 94. So now our perimeter of JKL, outside one, is 84 plus 94 plus 98. So 84 plus 94 plus 98 gives us 276 for our perimeter of JKL. Now the perimeter of MNO, which we can make a prediction about. So if I knew that 84 was the side, and half of it was the side here, could we also say that maybe it's half the perimeter? And let's look. So we got 49, 47, and 42 comes out to be 138, which is also half of 276. So in a midsegment where the side is double the midsegment, or the midsegment is half the side, the perimeter would also work the same way. Now for our last two. So this one is going to use the fact that we have parallel lines, and by parallel lines we're going to use some of our angle pairs to solve, as well as triangle rules. So first off, I know, so if this is 127, B is going to be 180 minus 127. So that gives me 53 degrees right there. Now, when I have parallel lines, and I have angles in the same location. We call them corresponding angles, which is what I have between A and B. Parallel lines, same location. So A is also 53 degrees. We have another set that work that way, so the 52 and D are both corresponding, so D is 52. If I know that D is 52, I can do 180 minus 52, because I have a linear pair, to find that E is 128 degrees. And then the last thing we're going to do here to find C is I have 53 and 52. I need to find angle C. So 53 plus 52 gives me 105. I'm going to subtract that from 180, and I get that C is 75 degrees. So by parallel lines, we can use our different angle and triangle rules to go in and find all of the angles. For our last one here, we need to solve for the values both x and y. And if we look at y, it does match to this mid-segment here, the 3x plus 10, but I can't solve for both x and y at the same time. I'm going to use these two to solve first, then substitute in to solve from there. So we're going to first say that BC is 2 times FE. So 4x plus 6 is equal to 2 times 3x plus 5. And we get 4x plus 6 equals 6x plus 10. I then subtract over the 4x and I get 2x plus 10. I then subtract over the 10, I get negative 4 equals 2x, so x equals negative 2. So that's this portion. Now I'm going to put negative 2 into the equation for BD to find this side. So 3 times negative 2 plus 10 gives me negative 6 plus 10, or 4. So if this is now 4, we need to find y. Well, I'm either going to double it or take half. I'm going to take half, so y is equal to 2. Now, upon further review, your notes may say here that 3x is actually negative 5. So I'm going to solve that way as well, just to clear it up if that's the solution. So we're still going to do the same thing. BC is equal to 2 times FE. But now when we make it negative 5, we're going to get 4x plus 6 equals 6x minus 10. By subtracting over the 4x, we get 2x minus 10 equals 6. We then add 10 over to get 16, and x equals 8. From here, I'm going to substitute in the 8 into x to solve for BD. So 3 times 8 plus 10 gives me 24 plus 10, or 34. Y is going to be half of the side because it's a mid-segment, so this gives us that y is 17. That's half of 34, and there's our two answers.